Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we learned how to read regression output in Stata. Now we'll do the same thing in R. The key idea to keep in mind is that R and Stata are showing you the same econometrics. They just organize the information differently. So keep that in mind and refer to the videos that have the software that you use in your own lectures. This is what a regression output would look like in R. So it's very different. We don't have that nice table we saw in R with all the different blocks being differentiated by the lines and so on. But the main idea is always the same. So we can see at the very top, this is the formula that we have used. It's the same as what we had in Stata with the reg. Instead of the reg, here we have slightly different. And the formula, so the model that we are running, it's exactly the same. You'll just notice that the syntax is slightly different, but we're using the same data set in here and we're using the same regression that we did before. So this is R being very explicit about what is the dependent variable, the regressors, and the data set used. So Stata shows the command you typed, but R prints the model specification also as part of the output. So same information, just different philosophy. Let's move to the next bit. It's residual summary. So R emphasizes diagnostics, which means here, this is like your residuals block. You'll have the minimum, the first quartile, the median, third quartile, and the maximum. So this is all information on the residuals. This gives a quick sense of like the distribution of the residuals, whether they are roughly centered around 0 or not. It's a difference that we have with Stata because Stata does not show this by default in the regression output. But as I said, R emphasizes diagnostics, and this is how it's highlighting diagnostics early on. A little bit of a reminder to always check your assumptions, basically. Then we have the coefficient table. Just like in Stata, the heart of the output is the coefficient table. And again, each row corresponds to one regressor. And then we'll have one last row, which is that of the constant. In this case, the constant or the intercept is the very first line. Then every other line in here is a new regressor that we're looking into. This part should be very familiar to you, and the information, it should also be very familiar. So we've got the coefficient. It's called estimate. We've got the standard error column. We've got the t-value, and the same concept will apply here as well. If you take your estimate and divide it by the standard error, these should give you the t-value and ultimately the p-value that is associated with this particular t statistic that you were given. Notice that while these columns are exactly the same and play the exact same role as what we saw in Stata, they just have different labels. And the only thing that we don't see in here is simply the confidence interval, okay? Otherwise, the t and the probabilities are exactly the same. And if you compare the numbers that you're seeing in this output with the numbers in the Stata output that you had in the previous video, you'll notice that they are the same. There is one addition to the information that you see in R that were not introduced to you through Stata. Look very carefully. We now have these stars appearing, and there is the legend that tells you what the stars mean right here. So we've got 3 stars. If it's like a p-value that it's very close to 0, if it is 0.1% significance, you're gonna see 2 stars. And if you have a 1 star that is 1%, If you have a dot, unfortunately in this table we don't have it so that you can see it right away, but if you had, let's say, a dot right here, that would have meant that this was statistically significant at the 5%, and then ultimately if anything is like 10% or more, there would be nothing, just like we have it in this particular case right here. Okay. This is some sort of like significant coding that R gives you. Keep in mind, more stars means stronger evidence against the null, and fewer stars mean weaker evidence, just like the legend had introduced in here. There is no rule on which output is better, whether that of Stata or that of R, because as we said here, the difference is Stata shows you the confidence intervals by default. Instead, R emphasizes the stars and the p-values more. They are just different defaults. So in that situation, you can actually get the confidence intervals directly from R as well by giving a certain command. And in this particular case, you can get the two numbers on your confidence interval by using this command conf interval in here. Okay, you can compare those numbers to the numbers that you had in Stata to see that they match. There's a little bit more information in this output that we haven't finished looking at yet. So we've got the residual standard error right here, and the degrees of freedom. So the R reports the residual standard error. This measures the typical size of the residual. Keep in mind, it's the same role as the root MSE that you had in Stata. It's the same object, just different name. The degrees of freedom here are made very explicit. So R explicitly reports them. And this matters a lot, as we know, when we make inference or we find critical values, anything including uncertainty. Keep in mind, Stata embeds degrees of freedom in the actual output, but R makes them very explicit. Then we've got the multiple R squared and the adjusted R squared given to you right here. Keep in mind, this is how much of the variation in the outcome is explained by the model. Same interpretation, same purpose, just formatted differently, but the numbers should match the ones that we saw in the Stata output before. And the F statistic that for Stata was in like the second block that we saw, along with the degrees of freedom, and an F statistic needs 2 degrees of freedom. That's why you have here degree of freedom 1, degree of freedom 2. And you've got the p-value that is associated with this F statistic. So this tests whether the regressors taken together explain variation in the outcome. So same as Stata, it's this joint significance test on the entire model. It's just printed at the bottom instead of the top. What R does not show by default, though. So one important difference, R does not show the confidence interval by default, and you have to ask specifically, as I showed you the output earlier. And in terms of like big picture comparisons between R and Stata, keep in mind, Stata is like table first, inference forward. R is object first, diagnostics forward, okay? Underneath all of that kind of philosophy that each of the two software use, keep in mind the econometrics is exactly the same. If you understand regression output conceptually, switching between Stata and R, it's literally just learning a new layout, not new econometrics. I hope this video was helpful, and I'll see you in the next one.